Hi, I'm Korey Stegared-Pace, and I'm a part of the AI Cloud Advocacy team here at Microsoft. Welcome to this Microsoft Build session, where I will be covering a journey into open source models with HuggingFace and Mistral. We're going to be taking a trip together in the world of open source, and like any good trip, we should start with a map. So the map that we're going to use is today's agenda, which first we'll look at what we're going to be doing in terms of planning the journey. So why use open source models at all? Which we'll be looking at some of the unique features that these models bring when we're talking about building generative AI applications. Then we're going to look at starting the journey. Where should we start? And in this case, we're going to look at how we can utilize the Azure AI Studio to work with these models. We're going to be also then taking two stops in this journey, as was discussed. The first one is with Mistral, and the second one with HuggingFace. If you're not familiar with either of these two things, don't worry, we're going to cover them in this talk. And then lastly, we'll take a final destination, which is deployment. How do we actually get these models into our applications and allow our users to use them in an appropriate way? So let's get started. Like I said, the first idea here is why use open source models at all? And with any sort of discussion and talk around open source models, I think almost always we talk about this idea of the Cambrian explosion of large language models. Normally, a slide like this is accompanied by a graph of all the models that have been released at a certain time period, whether it's the last month, the time between GPT-3 and now. And the idea as well is that we are receiving so many models being released that I didn't want to include this chart because surely even after you viewed this, that chart could be out of date rather quickly. But I think it's a unique opportunity and understanding of how layers of large language models work in this ecosystem. So first, new models are being regularly released, whether that could be on a weekly basis, a monthly basis, or 6 months time. We continue to see new large language models with new capabilities, whether that be in performance or in cost. And you need to know what kind of keep up to date on those sorts of things. But another important part that we're going to talk about today as well is that these older models are not obsolete. It's not like a consumer device where you need to rush to upgrade to the latest device to get the best features. These old models are still very powerful, and they actually have a good use case in terms of what we were working with when we were talking about building with generative AI. And then the last part, right, is that these tools that we use and developers like yourselves need to keep up pace, which could be seeming like an impossible task. But hopefully after today's discussion, we will look at how we can sort of ground ourselves in the world of open source models and the way and the pace of change that's coming about. So in order to give us the right directions, right, we need to have a compass. And this is going to be the open source compass. So when we talk about open source, mainly we look at proprietary versus open source. And proprietary models, in case you don't know, are typically owned by a certain company and have a limited licenses in terms of how developers can use it. This fits into the label of when you're working with the Azure OpenAI models. But on the other side of things, you can look at the open source models. And while there's been many discussions and debates on what fits in the definition of open source models, typically we can look at things like the license, whether it's how it allows for modifications or free use, either from developers or researchers. That there's generally some open weights that have been exposed so that we can modify these weights through the process of fine tuning, which we will also discuss later on. And on an average, they're actually cheaper than working with some of the proprietary models. And naturally, when people hear cheaper, maybe they think that they're missing some sort of features or there's some sort of catch in terms of why they're cheaper. And it's not necessarily so in terms of working with open source models. They actually deliver, in most cases, comparable performance to proprietary models, and also in some cases, better performance. We're actually going to look at why that's the case from an architecture perspective. And then lastly, there's a lot of community around that has led to innovation, whether that's fine-tuning and making fine-tuned models available to you as a developer for specific use cases that are quite important to what you're building with your application. But I think that the proprietary versus open source, well, that's an understanding to understand differences. What we're actually seeing more and more is that applications are being deployed with proprietary and open source. What this means is that you're actually using multiple models, whether that's a proprietary model or an open source model, for completely different or distinct tasks. And that could be down to a variety of factors, whether it may be the different cost models that you're working with, or the different performance as well. And if you look at kind of where that division lies, we can look at certain things like model task, whether it might be summarization, which a lot of large language models excel at, where you don't necessarily need the most powerful or most latest model to perform, and you can get some cost management benefits with that. Maybe also a model excels at things like text to SQL or working with other specific spoken languages, where that model could sit within your workflow or your architecture, which makes the most sense. And then we also talk about other methods like search or retrieval augmented generation. How do those models sort of perform within that architecture? Maybe it will make you differentiate which models that you kind of sit within that process to perform those operations. This could also be very use case driven. Whether certain queries need to require low latency, maybe if this is like a chat application or where users expect responses rather quickly, or even in the type of responses. What we also have seen is that some models respond with different links or different form or style that could be very important to your use case or how your users are interacting with the model. So again, choosing the right model for that particular use case makes the most sense, whether that be a proprietary or an open source model. And then lastly, probably more importantly as well, which we'll discuss later on, is the context windows. Especially when we're talking about things like search or retrieval augmented generation, having a larger context window could provide some benefits in terms of being able to give the model more information. And in case of your workflow and your architecture that you're working with your application, a proprietary or open source model might benefit that, while maybe summarizing is going to be used by another model. So I like to think proprietary and open source will be sort of driving the future in terms of application development in the world of generative AI. So like I said, now we're going to start this journey. We kind of know the directions that we want to go, whether it's looking at how these open source models have unique benefits, but how do we actually get started working with them? And in this case, we're going to look at the Azure AI Studio. So within the Azure AI Studio is the model catalog. And currently this has 1,600 plus models available. And I put the 1,600 plus available because this model catalog continues to grow. And by the time you watch this, there'll probably be even more models available. So know that this is a good opportunity or a good place as a repository to find both proprietary and open source models. We have collections that are including Microsoft Research, who has been making great breakthroughs in terms of the world of small language models lately. HuggingFace, which of course is what we'll discuss later on, Mistral AI, as well as other providers like Cohere and Meta. The model catalog also allows you, because again, since there's so many models, it might be very hard to find your way through the trees, if you will. So we also have available features in terms of filters in terms of inference tasks, whether that be summarization, chat completion, generating text, or even embeddings, especially when we're talking about working with retrieval augmented generation. These are also very important tasks that need to take place in your process or workflow. And being able to find the right model for the right case allows you to do that by using these filters. Additionally, which we'll talk about later on, is fine-tuning tasks. So these are models that have been generated or trained for a specific task, and you can also find those models within the model catalog by filtering, whether that's for translation or image classification, or even doing some multi-object tracking, which is a good use case in terms of working with the images that you might be having within your application. So it would be a miss if I were to say that, well, given that these open source models have a lot of flexibility, they also have a lot of flexibility on where you deploy these models. You can even work with them locally on your machine. Maybe you've already done that before. So why would you want to use the AI Studio is probably another question that you might be asking yourself. And again, the addition of the model catalog is a nice way to, one, understand and be a central place to explore those models in terms of discovery. But we also have integrated features in terms of fine-tuning these models, which allows you to have a customized model for your specific needs. and that's all within the AI Studio. But I think even more importantly is around even evaluating the model in terms of performance, as well as we have comparison metrics built into the AI Studio, so you know exactly how the model performs in certain accuracy metrics, whether that be coherence or fluency. And then lastly, deploying, right? Uh, Being able to use these models at scale and into the scale that you need or require for your application is very important. You won't be able to run your local machine on an enterprise level application. So you need to find a way to actually deploy these and serve it to your users in a good way. So with all of these sort of benefits, the AI Studio makes the most sense when you're looking to operationalize these models at a scale that your users and your application demands. So now that we've got an understanding in the first place we started, let's take our first stop at Mistral. So Mistral has some differences and unique benefits that I want to talk about, because again, the idea of around, oh, a model might be cheaper, so maybe it's missing certain things, is a false one in most cases. In this case, Mistral actually has benefits because it actually operates with a modified transformer architecture. Transformer architecture drives a lot of these large language models, but Mistral has a unique take on it because they actually use what we call a mixture of experts. And in this case, an expert is a neural network within them in this model. And in the case of Mistral, most models have a mixture of 8 experts. And at the time of inference, what happens is that 2 of these experts are selected, and a weighted average of their predictions is what is actually being presented or served to at inference point. So what this allows you, the Mistral model to do is actually deliver the performance of larger models without actually not necessarily being large in size, which relates and translates to a much lower inference cost. So in terms of this model being cheaper, it's not that you're losing out in performance, but the architecture leverages the resources available in a unique way. Mistral also has some added developer features that maybe you also have experience in some of the proprietary models as well. So in some models that are available, it has native function calling, which we'll actually look more into depth. But we also have things like safe mode, which allows for unique guardrails when you're building chat applications, where essentially each prompt that you send to the model also has a sort of safety prompt included. And then lastly is the JSON mode. It's important to know that, when you're working with large language models, it's not that you're just working with a large language model, but the application as a whole. And with JSON mode, you can retrieve all the responses from the model in JSON format, which makes it really uniquely better for integrating and working with other downstream systems that you might be having in your application. So these are some unique benefits that Mistral models have to offer. Another unique benefit with Mistral is there are actually many models available, specifically in the model catalog. So just to show you the 4 main models that are available, we'll start with the first model that we won't talk too much into detail, but that is the Mistral Large model. This is their flagship model, and the reason why I say that we're not going to talk about it as much is only because this actually sits within their commercial license, so it's commercially optimized model. So it doesn't necessarily fit into the open source definition of what this talk will be talking about, but it's also good to know when you're looking at the entire Mistral catalog. It has a 32 tokens context window, which is also, and performance-wise, would be comparable to a GPT-4 model. But looking at the open source models, we'll start with Mistral 7B. And this was their first introduction into working with open source models. There's a 7B Instruct Tune model as well available, which is the chat generation model. And Instruct Tune is basically making the model fine-tuned in a way to work with chat applications. So it knows that questions are going to be asked and a response or an answer is expected as from the user. It's extremely lightweight, so that's been one of the major benefits of using this model. It actually sits on essentially 1 GPU, so you can work with it very well in low intensive resources environments, and also has a 32K token context window. When we look at this compared to other models that are out there, it sort of outperforms now Llama 2. And then when we obviously we have that model available still in terms of what its benefits it can bring, but there's been upgrades to this. So Mistral 8X7B, which is another mouthful of names, is also a open source model, but it provides faster inference in compared to the 7B model. It also includes an instruct fine-tuned model that does chat generation. And from performance or use case wise, we've seen a lot of gains in terms of it excelling at doing code generation. Similar to the other models, it's a 32K token context window. And if you want to compare that to a proprietary model that's out there, it's comparable to a GPT 3.5. And lastly, one of the most recent models that have been released, actually released this month, is the Mistral 8X22B. It's been noted now as probably one of the most powerful open source models that are out there. And it's actually the first supported model that has the function calling feature natively supported. Mistral has 3 commercial license models, the small, medium, large, and those all have function calling as a native support. But Mistral 8X22B is the first model of open source to do so. It has a very large context window of 64,000 tokens. And from a performance as well, it's outperforming a lot of models on both coding and math tasks. So again, when you're trying to navigate the world of open source models, it's definitely important to understand where these models excel at and set them into your workflow, your processes, where they can provide the best value for sure. So I want to look at this function calling feature because I think that's one of the things we see in some of the proprietary models out there, specifically the OpenAI models. It's been a great feature and a great value. So how this is actually implemented in the Mistral models is essentially tools are functions. So if you have a function in your application that can be viewed as to the large language model as a tool to execute or work with. So in this case, we have a basic function, which is going to retrieve sort of a payment status. It has a data frame with some data and also a transaction ID, which is a string. Basically, we're going to do a lookup on that to find if the transaction ID is included in that data. If it is, we'll return the payment status. And if not, of course, we're going to say the transaction ID is not found. So this is a function in our application. Next, what we need to do is define some tools. So we actually need to define this as a tool available to the model to operate with. And that is by defining it in a tools array. So we are going to go ahead and say this is a type of a function. We're going to just give it the name of that function. A description is for the model to also have a better operation understanding of what that model, the function does, and the parameters that are needed. So in this case, we need a transaction ID, which is in the type of string. And then it's also required when you need to operate this function that the transaction ID is present. Next, what we will do is actually store these tools. So we actually store them in a data frame. So we'll have this retrieve payment status. We'll bring in the partials of the Python code and also the function as it's named in our application. Next, we'll actually need to do is set up the Mistral client. So we have the importing of the Mistral client as well as the chat completion. And we'll set our endpoint. In this case, it's just the generic endpoint and your API key. After we've done that, we need to set up the actual chat. So we can do that by using the client.chat, pointing to the model that we're using, in this case, the Azure AI model that was being hosted at Azure the AI Studio. We'll have a role, and then we'll also designate some content. So in this case, the user is asking what's the status of their payment. So once we receive the response, we'll have the client.chat. We'll point that to the model that we defined, the messages that we just defined, and the tools, again, the functions that are available. And we also have this tool choice to auto. We can also have other settings where we can turn this tool choice off or even force the model to choose a tool depending on your use case. And that might be a pivotal or important step. So it's up to you, and that gives you some more flexibility as a developer. Next, we're actually going to read the tool results. So we actually are, in this case, taking the function name. We're going to load the JSON that we receive. look at the function, the parameters of the function name, and the parameters of the function that we need to pass for the function to be executed. We'll also set that to the function result, and save the function name and parameters, because the next step is actually generating that response. So in this case, what we're going to do is execute the function. And again, what's important when talking about the Mistral function calling is that you, as the user or the application developer, need to execute the function. This is not an automatic process. But we also then will take the chat message. We're going to append both the role of that, which is the tool, the function name that we resulted, and then now the content. So in this case, we're going to receive back a status of the repayment, and then we're going to send that to the model to include into the message and the response that it's given. So it's not going to necessarily just going to be, hey, your payment transaction ID is X, but maybe depending on how we prompt this chat model, maybe give it a nice friendly message at the beginning, but giving it a very assistant-like experience. So that covers Mistral. Our next stop on this journey is HuggingFace. So the HuggingFace perspective, or I think where a lot of the value from HuggingFace comes, is this idea of working with sort of module AI models in terms of building applications. So HuggingFace currently has around 600,000 models available. And for this talk, we're not going to cover all of those 600,000 models that are available, like we did with the Mistral models. But know that there's many models available, and they all have very unique or specific tasks, whether they're even multimodal models or things that, in terms of inference tasks, very similar to what we just showed in the AI Studio. I like to think of this concept of sort of building AI applications like Legos. So there's different blocks, different AI models that do things, and you sort of need to pull and choose those models that excel at what they do, whether they're a longer block or a smaller block, but they need to fit into your entire AI application story or development to complete a certain task. Of course, there's also multimodal models that are available, like llama 3. So you don't necessarily need to use a model for specific tasks. You can have models that do multiple tasks or actually accept different inputs. But I think what's important when you're working with HuggingFace is that you need to also then understand the inference or fine-tuning tasks to get the best performance of your model. You don't want to put a Lego block that doesn't necessarily fit into your application because it's not performing really well. So understanding where those things, where they excel at, is going to be very important when we're talking about HuggingFace. I think another great unique benefit around HuggingFace is the developer community. So within HuggingFace is the HuggingFace Hub, which you'll find things like discussions from with developers who are working with the model, which is a great opportunity to find ways that you can get better performance. Maybe there's certain issues or certain use cases that the model didn't perform well on. And this is all within this discussion. There's also a quite strong community around fine-tuning. So also finding fine-tuned models that are very specific to use case, whether it may be a language or an industry or a specific area of knowledge, is another amazing opportunity we're working with HuggingFace. And then lastly is these model cards. You can think of these if you're familiar with like GitHub READMEs, but they tend to have a lot of details on how to work with the model, certain benchmarks that the model is performed in, and also even some advisements on how to get the best out of the model. Like I said, HuggingFace has 600,000 models available in their model catalog or model hub, but all models are not necessarily available directly in the Azure AI Studio, but we do have an ability to request those models. So if you see a model that you think definitely fits into what your opportunity is, do use that feature very wisely in terms of bringing those models within the Azure AI Studio for working with as well. So just to give you this idea in more of a visual of what I mean by building with multi-models or even this kind of Lego block concept, let's say we have this application, and I'm based in Stockholm, so I'm going to use a very local example for you. And we have this Finnish speaker, and maybe they're dealing with Swedish content, whether maybe this is maybe they're working for a Swedish company and all of their documents in this case for right now are in Swedish, or they're a Swedish customer to yours, or sorry, a Finnish customer, and all your website content is in Swedish, or your database is in Swedish, things like this. So they want to interact with your application or your document or whatever is needed from a user perspective. So we could use a model that's actually specialized in working with translating Swedish to Finnish. So let's say in this case, from the Helsinki University, there has quite a lot of NLP or translation models that have been fine-tuned. And in this case, this model has been fine-tuned to be able to translate Swedish to Finnish really well. And what you'll find is, especially in the larger models, even though they've been trained on large amounts of data, even let's say even certain languages where maybe there's a smaller population or smaller content that might be in their training data, while they certainly can perform really well on doing this test, Swedish to Finnish, maybe a model that is specialized in that will probably have more benefits to your application. So we have this model now that can take the Swedish to Finnish content, take it and to translate to Finnish. And now we want this Finnish speaker to probably have the same, user or customer experience that we have with the Swedish customers or Swedish speakers. And in this case, in our application, right, we might have a way for someone to interact with the model through speech to text. So saying something and then get a response back, whether that might be, even text to speech or just in text. So in this case, we might want to use a 𝗦𝗲𝗀𝗀𝗀𝗲 model that has been also fine-tuned to Finnish. So in this case, it's also available on HuggingFace, this 𝗦𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 v3. Then I will go ahead and take the speech or whatever the Finnish speaker is saying and convert that into text. And then lastly, generate a response using basically a version of Finnish GPT-3 that does text generation, but also, again, very fine-tuned to Finnish. So this is GPT-3 Finnish small model available at HuggingFace and as well as in the Azure AI Studio. And in this case, now I'm delivering an experience using 3 models that are very fine-tuned to this specific task. And you might be asking like, oh, wow, this is a lot of models and maybe the cost would be significantly higher than just using one model. But again, since these models are fine-tuned and in open source, you can actually get a lot of performance benefits and not necessarily have a dramatic cost increase or any cost increase in terms of working with these models instead of one larger model. So the final destination after we've maybe choosing the model, maybe we build Lego blocks with HuggingFace, is the deployment side. And again, that's where the Azure AI Studio really shines out. So we have 2 sort of pathways for you in terms of working or deploying these models. The first one is the models as a platform opportunity to deploy. And again, this all depends on certain models as well as certain regions that you're deploying to. But this essentially allows you to import, fine-tune, evaluate these models, much like you would do anything else in terms of working with Azure AI and Azure AI Studio. Again, like as I mentioned, you're still having the opportunity to use the model catalog. So all of the models that we just discussed just now, as well as the meta models and even like Cohere models are all available there. And it includes the shared compute resources. So you can even have temporary endpoints which for testing, which is rather important when we're talking about deploying these large language models into an application. You want to make sure that they're thoroughly tested, and the Azure AI Studio provides you that flexibility to do so. The other model or pathway in terms of deployment is a relatively newer one as well. And this is model as a service. So instead of having a dedicated endpoint to using these models, you actually have a ready-to-use API. And it actually, in terms of billing, is a pay-as-you-go. So what that actually means is in terms of cost is that you're actually paying only for the tokens that you use when you're utilizing this model. And right now, there offers access to 𝗦𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 and Mistral is a Mistral large model as an inference API. But again, these features are continuing to grow and develop. So I could see an opportunity later on in the future that more models will be available for this model of deployment. And this also works really well in terms of integrating that into other large language model tools that might be in your stack now, whether that be Promptflow, which is a great way and a great tool in terms of being able to look at how models are performing side by side. So you can deploy multiple open source models, for example, and see which one fits your use case, both visually and also breaking down from an evaluation standpoint. but then also the chaining tools that are out there in terms of semantic kernel and LangChain, all you kind of natively support using an API in terms of integrating with them. So this is where the model as service really shines. And then lastly, there's serverless fine tuning. So you don't necessarily need to provision using GPUs for that. And again, from a cost perspective, probably it makes the most sense for certain use cases. But this is going to end our journey in terms of what we had put on the agenda. But hopefully that does not end your journey in terms of working with open source. So I wanted to give you a few pieces of content and other learning materials that are out there to help you really get started, because we only discuss things, but hopefully you're now excited to start building with these models. And the first one, so I'll show you, is the 2 code samples that we have available at these certain links that gives you an understanding of not only how to work with these models, but specifically how to work with them within the Azure AI Studio. And this is a great opportunity and great sort of template to get started with. So we have one for Mistral, which is a sample there, and then HuggingFace, which we actually have multiple model types and examples there, but I showed you one that's specifically sharing with you specifically for translation, largely because that's the example that I gave. But do explore these repos, because that's a great place. And they actually, some of these code samples are linked directly within the Azure AI Studio. So if you see a model, you probably also see an example of using that model, and can really save you a lot of time in terms of development as well. And the last set of materials I want to share with you is our Generative AI for Beginners course. This is actually completely free on GitHub and is an open source repo, so you can also contribute to them in terms of finding improvements. We have lessons covering things like introduction to generative AI applications, comparing different model types, even the type of application that you want to build. But specifically, since we covered open source models, I've linked you directly to the open source models lesson. And it just so happens that I'm the one that created it, so I'm a bit biased, but please do check it out when you get an opportunity. And then lastly, to keep the discussion alive, because like I said, some of the core unique benefits of working with these open source models is the community itself. People are very open in terms of how they're working with it, what the performance that they're getting. And we have also developed a community within the Azure AI side of things. So we have the Azure AI Community Discord, which you can join from this link. And there's always going to be an opportunity where you want to ask. There's employees in Microsoft that are in there, MVPs that are product experts, as well as just general community members. And we also have community calls covering pressing topics that developers like yourself might be interested in when you're talking about working with these models. So that brings us now officially to the end of our journey. But like I said, I hope this is actually the start of your journey into the world of working with open source models. Specifically now, we were talking about HuggingFace and Mistral, but there's a whole world out there in terms of what the model providers and what these models can bring to your applications. So I'll leave you with that and say happy traveling, and I'd love to see you in the Discord later.